last video. Congratulations. So this will be 13.4 notes of our trig unit in the last video in this unit as well. So let's go ahead and get started. So to find the measurement of angles given the value of the trig function, you must use an inverse trigonometric relation. Just so you know, instead of calling these inverse sine and inverse cosine and all of that, you could also call them arc sine, arc cosine, and arc tangent. Okay, so for the function, to find the value, we have the sine of theta will equal a, cosine of theta equals a, and tangent of theta equals a. So if you don't know what theta is, and you could set it up in your equation equal to whatever it is you found. So if you want to solve for theta, then we would have sine to the -1 of a equals theta. So in other words, this will say the angle whose sine is equal to a will be theta. Same thing with cosine and tangent. Okay, so we talked about in class that you need to have your calculator set into degrees, so make sure you've done that in either a document or the scratch pad depending on which one you're working in, or both. It never hurts to just go ahead and do both. Let's go ahead and look at an example of how to use these inverse trig functions. So here's our example. A group of hikers wants to walk from a lake to an unusual rock formation. The formation is 1 mile east and 0.75 miles north of the lake. To the nearest degree, in what direction should the hikers head from the lake to reach the rock formation? So first of all, here's our picture. There's that 1 mile to the east and 0.75 miles north. And we're getting from the lake to the rock. And so then we are looking for in what direction. So we're looking for this theta right here, this number of degrees they should head. Okay, so from theta we have the opposite and we have the adjacent, which means we'll be using tangent. So we'll have tangent of theta equals 0.75 over 1, which is just 0.75. So we know that the tangent of theta is equal to 0.75, but we don't know what theta is at this point. So we would rewrite it as seen here, that the tangent to the -1, or inverse tangent, or arc tangent of 0.75 will give us that theta, and so then you would type that into your calculator and you'll end up with 37. You'll notice that we have an N and an E right here. That only applies whenever we're looking at north and south stuff. So what this is saying is my theta is the 37 degrees. So if we're headed east, then we'll go 37 degrees north of that. So we would go that direction. So then that 37 degrees, so we go north 37 degrees of just going east. So if that kind of confuses you, don't overstress about that. You won't really see much of this, but just so you can understand what you're looking at here. Okay, so inverses of trig functions are not functions themselves. In order to define inverses as functions, you must restrict the domains. When this restriction is used, it is noted by using a capital letter. And maybe you notice that capital letter when we use this inverse tangent up here. But let me explain to you using graphs first, and then we'll come back and look at this. So here's a graph of sine of x, so it makes this wave here. If you looked at cosine of x, it makes a wave as well, just in a different spot than cosine. Tangent, kind of crazy looking, it's all of these swoopy vertical lines. But then if we want to look at their inverses, so on your calculator next to the number 7, underneath that trig menu, you can see we have sine, cosine, and tangent. We've got all of their inverses along with the reciprocal functions here, cosecant, secant, and cotangent. But back out of that, so if we wanted to look at the inverse function of sine of x, remember we would have to reflect that over the line y equals x, and you can also figure out if the inverse would be a function by using the vertical line test. Well, if you ran the horizontal for the original, so you would get a vertical line test on the inverse function, but if you looked at a horizontal line test on the original, you'd see that we would hit lots of points as we move the line across. So what we have to do is, let's go over to our inverse. So I just typed in the inverse sine or arc sine of x. I didn't do anything else, but you'll notice that instead of having a bunch of waves, we just have a little piece of 1. And that's because if it kept going, it would have kind of waved back and forth around the y-axis, and that would not have been a function. So we have to restrict the domain on the function. Whoops. Okay, so then that would be the arc sine. Arc cosine would look like this, and then arc tangent would just look like this, just one of those swoopy looking lines. So now let's switch back over to our chart. And you can see we have, so for the inverse sine or arc sine of A, we would have to restrict the domain between -1 and 1. And if you look back at our graph here, our x values went from -1 to 1. On cosine, it also went from -1 to 1, but tangent, it has a lot more x values here. In fact, it has all of them, so it has all real numbers for its domain. So that's why you see for the domain of arc sine, we've got -1 to 1. Inverse or arc cosine, we have -1 to 1. And then for the inverse or arc tangent, our domain is all real numbers. Then we can look at the range. So you can see it's kind of hard to tell on this graph, but we are going from -pi/2 to pi/2. And maybe this would kind of help you visualize. This is the unit circle, and it's a much more detailed version of what we have in our notes. But a couple of main point things here. So we've always said the initial side of our angle is going to be on the positive or the right side of the x-axis. So that will be where our 0 is. And that is our unit circle's 1 unit. So it'll go 1 unit out to the right, up, down, and left. So if we go to the right 1, that's the point 1, 0. If we go up 1, that's the point 0, 1. If we go to the left 1, that's the point -1, 0. And if we go down from the origin 1, that would be 0, -1, which is there. I just didn't have enough space on my screen. So then that would also be 0 degrees. A quarter of the way would be 90. Halfway would be 80. 3/4 would be 270. And then we'd be back at 360, which is at 0. So then you can see in the red and the blue on the insides here, those are the degrees as well. So if we have 90 as a quarter of the way, half of that even would be 45 degrees. But we also have 30 and 60 because our two special right triangles, 30, 60, 90, and 45, 45, 90, all of those angles are represented here. We've got our actual points. So remember the ratio of the sides for a 30, 60, 90 and a 45, 45, 90. If you looked at in blue, that would be the 30, 60, 90 triangles. If you looked at their cosine, that would be your x. And if you looked at their sine of 30 or 60, that would be these y values. 45, 45, 90. Cosine and sine are right here. And then this pi/6, pi/4, pi/3, those are the radians. And if you're using those units, that's when, of course, we would have our calculator in radians. But we've been using degrees, so these inner piece of information. But just so you know, 2 pi is all the way around. And of course, if our radius is 1, then our circumference would be 2 pi r, which would be just 2 pi. So all the way around is 2 pi. So then halfway around would just be 1 pi. Half of that would be pi/2. But then if you went 3/4 away, that's 3 pi/2. Don't let this overwhelm you. We're not going to use too much in detail, but just for those of you who wanted to visualize it a little bit and see where this information comes from, just wanted to help you out. So let's switch back over to our notes, which are much less detailed. This is the kind of stuff you'll use in pre-cal all the time, though. All right, switching back over. Our range, so if our domain was between -1 and 1, then that means, here's our very simplified unit circle to the right here. So that was, if our domain is from -1 to 1, for the sine, then for the inverse sine, we will have the y values going -1 to 1. So if you're getting confused about this picture here, this is shading what would be for the sine, but these are the restrictions that we have to place on it in order to get the inverse of sine. Then there's the same thing with cosine and tangent. I understand this may be a little confusing for you right now, but just kind of look at these pictures, try to understand what we're looking at, and actually that's it for this video. We'll do a couple of examples together in class of the things that you're going to need to know as far as this year, but next year in pre-cal you're going to be doing so much more with it. Alright, thank you for watching this year's videos with me and sticking with it till the end. I appreciate you guys doing that, and I will see you in class. Hope you're having a great day. Bye.